as far as extension is concerned, when it comes to integration and inverse trig, we don't actually integrate the inverse trig functions themselves. We'll do that in extension 2, but at an extension 1 level, it's merely going backwards. So, if I wanted to integrate something in the form of dx on the square root of a squared minus x squared, then I know it must have come from the inverse sine, or the inverse cosine for that matter, function. And it must have come from, because that's in the format of that when it's a linear function, x on a. So if I've got the integral dx on the square root of a squared minus x squared, it's inverse sine of x on a, but an equally correct answer would be minus the inverse cos of x on a. Because if you recall, when you differentiate inverse sine and inverse cos, you basically get the same thing, but one's plus and one's minus. Later on we'll see an application, simple harmonic motion, where it is useful depending on initial conditions. Sometimes we choose inverse sine, sometimes we'll choose inverse cos. Really depends on the problem that we're looking at. And then the inverse tan one, what we have to be careful with is the 1 on a out the front. Because if you recall, when it was in the linear function way, it had a on the top, a on a squared plus x squared. So this one has 1 on a out the front. So if I see dx on the square root of 4 minus x squared, well then all I really need to work out is what is a. So inverse sine of x on 2. 9 plus x squared, again we'll work out a, but we need 1 on a out the front for inverse tan, so we get 1/3 inverse tan x on 3. Let's do a definite one. Be careful, because a in this case is not 2, but it is the square root of 2. So we've got inverse sine x on root 2, we're going from 0 to 1, so the inverse sine of 1 on root 2 minus the inverse sine of 0, 1 on root 2, pi on 4, isn't it? So pi on 4 minus 0, which is pi on 4. This is one of the ones where it's giving us a bit of a hint. So if I had to guess right now what that integral is going to be, what do you think I'm going to guess it is? Yeah. That'd be what I'd logically guess if I was going to guess. It might end up being some multiple, but let's have a look. Problem with this, I suppose it's not a problem because they haven't told me what the derivative is. But to differentiate this, I'm just going to write, well, I know it's the derivative over the square root of 1 minus the function squared. Oh look, that's the integral. So it sort of has a feel like I've cheated, but they haven't actually said, hey, this is the answer. So I think it's okay. I can just write that down. E to the x over the square root of 1 minus e to the 2x. Hence, well, if I differentiate the left-hand side and get the right-hand side, then logically if I integrate the right-hand side, I'll get the left-hand side. So we can go and find our integral. So we must go back to the inverse sine of e to the x. We're going from minus log 2 to 0. So we're going to play around with our log laws. So sub in 0, e to the 0, well that's 1. E to the minus log 2. Now e to the log would cancel, but I haven't got e to the log, I've got e to the minus log. So before that cancels, I have to bring the negative inside the log function. So it becomes 2 to the power of negative 1, 1/2, and so that's how I get a half there. So before you can cancel your e to the log, it must be e to the log, not e to the minus log. That's no good. Alright, let's work it out. Pi on 2 minus pi on 6, which is pi on 3. Uh-oh. That integral we had was a squared minus x squared. Damn it, I've got 9x squared. What to do? I know. I'll factorise the 9 out, so I've got a squared minus x squared. There you go. So now I've got dx on 3 outside of 4/9 minus x squared. Well, I can bring the third out the front, and now I've got it in the form the square root of a squared minus x squared. A in this case would be 2/3. A would be 2/3. So we get 1/3, the inverse sine of x on A. A was 2/3, invert, multiply, we get 3 on 2.